Hello everyone, well what an update we have for you here. We've got the first Winter 2020-21 update part 1 for you right now. So here we go, we are back into another season of winter updates. It only seems like 5 minutes to me since we finished the last season of winter updates at the end of November 2019, but here we go, we are back into another season of winter updates. We're going to be doing winter updates every week from this week all the way to the end of November, and then we'll be releasing the GavsWeatherVids Winter 2021 forecast at the beginning of December. I haven't got the exact date for you yet. I don't know exactly when the forecast will be released, but it will be early in December as it usually is. So, yes, and we're doing things a little bit differently this year. So, as I said, this is the first Winter 2020-21 update, part 1. That implies there's going to be a second part to this, and there will indeed be a second part to this. And that second part will be focusing on analogues, and that's going to be released tomorrow, Monday, at 8 PM. So this part 1 is going to be focusing on things like sea surface temperature anomalies, what's happening with Enso. We're going to be looking at solar activity. We'll be looking at Eurasian snow cover, although there's not much snow cover to look at this point, but later on in the season, Eurasian snow cover, Arctic sea ice extent, what's happening with the hurricane season, all of that stuff will go into this part 1, and then the analogues will be for tomorrow, part 2. And I'm splitting these updates up so that the running time on the videos, on the updates, is a little bit more manageable. I'm hoping to bring this out somewhere around half an hour, maybe a little bit more, so somewhere between 30-40 minutes probably will be the run time is, but it shouldn't stretch out like for an hour, hour and 10, hour and 15, possibly hour and 20 minutes like last year's winter updates were doing. So combine the two parts and it will be like an hour still of an update, but we're splitting it into two parts. It makes it easier for everybody to watch it, I think, and it also makes it a little bit easier for me to record, upload, process upload, and all of that stuff to the channel. So a very big change with the winter updates. I have never done winter updates in two parts. I've always done them just in one video. It's just that they've got longer and longer and longer as we've gone on and added more stuff in. So it's a very big change for me. It's a very big change for you. We'll see how it goes. If it doesn't work, then we can go back to bringing the winter updates back into one whole video. But I want to see how this works, and hopefully it'll go okay. And if it does, then it's going to be really, really helpful, I think, for everybody to be able to watch these videos, and also for me to be able to record them and process them and upload them and so on. So we'll see how we get on with that anyway. Right, so I'm going to tell you that, of course, even though we are doing this in two parts, these are going to be long videos, as well as with long range stuff, so you can't watch it all in one go. The video we place on Winter Updates page with a written summary going over everything that we discussed in the video. I'll probably get this part 1 onto the Winter Updates page at GavsWeatherVids.com tomorrow morning, I would have thought, with a written summary Monday morning, and then part 2, which will release on Monday night, will probably end up on the Winter Updates page on Tuesday morning. Something like that will probably be the way we go on with getting these updates onto Winter Updates page. But eventually, all of the videos we place onto Winter Updates page at GavsWeatherVids.com, there will be a written summary that goes with those as well. So you'll be able to watch the videos on demand at website and also at the channel, and you'll be able to read written summary as well. I'm going to say a big thank you to Richard Traw, big thank you to Richard for the fabulous Winter 2020-21 updates GIF. It's absolutely incredible. Thank you so much, Rich. It's one of the best GIFs that you've done, I think. I absolutely love this winter updates GIF, so thank you so much, Richard, for doing that. I'm going to say a big thank you to Shryan as well. Shryan Bruin has helped with this video as well, and I'll tell you where Shryan's work has come in as we get to it. The last thing I'm going to tell you is that James Ackrill has retired, so James will no longer be producing analogues for us, unfortunately. I'll still be doing them though. So I'll be doing the analogues as I have been doing for the last several months as well. So big thank you to James for all of James's help over the past few years with the analogues. Thank you so much, James, for all of the help that you have given us. And I know you'll be watching the video. Thank you so much, James, for everything that you've done in terms of the analogues over the past few years. Thank you so much, James, for that. Right, so let's get on then with the first Winter 2020-21 update from GavsWeatherVids. Here we go. We're going to begin with solar activity. So this is how the solar disk is looking on our side of it today from solarham.net. So we have a completely spotless solar disk. There are no sunspots whatsoever on the solar disk, and therefore solar activity is at very low levels, and it's expected to remain at very low levels. We believe this is going to be the first winter of solar cycle 25, though we have not had confirmation of that, but we think it's very likely this will be the first winter of solar cycle number 25. James will still be sending us the GavsWeatherVids solar activity tracker for the winter updates, so thank you very much to James for sending through the GavsWeatherVids solar activity tracker. Here we go then. So with this, the orange line is depicting each individual day's worth of solar activity. You can see that at the moment solar activity is actually flatlining on the floor of the chart. We did go through a slightly more active phase. Went through a slightly more active phase like back in at the end of July into the early part of August, but over the past week or so we have been in a pretty inactive phase with very little in the way of sunspot activity, and that means that our trend lines, which are the thick green excuse me, the thick green and thick red lines, they are actually ticking up. They're ticking down, I should say. So back in July and into August, the trend lines, the thick green, thick red lines, they did move upwards. Very small incremental amounts, but they did move upwards a little bit back earlier into like late July, early August. But now with the orange line flatlining around the floor of the chart, you can see that the trend lines are indeed ticking downwards once again. So we are at a very, very low level of solar activity. And whilst we have seen a little bit of an increase in solar activity, I mean, we're talking about very, very minimal levels of solar activity. And so I think we're like just coming out of solar minimum, and we're in the early stages of solar cycle 25, but it's going to be a slow process. I think it'll be very similar, I would imagine, to what happened at the beginning of solar cycle 24. Around 2009, 2010, where we had a very, very slow movement into solar cycle number 24. So I think we're going to have that again for solar cycle number 25. Thank you so much to James for sending through the GavsWeatherVids solar activity track. You'll be seeing that every week through this season of winter updates. This is from our good friend Richard Trott. So this is showing spotless days and the current spotless stretch. So actually, the current spotless stretch is 16 days. So it's over 2 weeks now since we last had some sunspots, and so that means that for 2020 so far we have had 172 days of the year without any sunspots. That is 69% of the year. That compares to 2019, which had 281 days, total days without sunspots. That was 77% of the year. So 69% to 77%. That's why I think we're in the beginnings of solar cycle number 25, because I think 2019 will be the solar minimum year of solar cycle 24. I think that's when we reach the minimum, and so 2020 will be like the first year of it'll be like first year of solar cycle 25. This will be the first winter of solar cycle 25. I think that's how it's going to play out. And I say, you can see how, like the last solar cycle, had a very, very slow movement into that solar cycle. So the actual solar minimum year for solar cycle 23 was 2008 down here, with 268 days of the year, 73% without sunspots. 2009, which is like the first year of solar cycle 24, has 260 days without sunspots, which is 71% of the year. So almost as weak with sunspots in 2009 as it was in 2008. And even in 2010, it's like the second year of solar cycle number 24, we still have 14% of the year without sunspots. So a very, very slow lift up into solar cycle 24. And I think what we're seeing for 2020 is telling us we're going to see something very, very similar with solar cycle number 25. So later on in winter updates through reanalysis, we will be trying to explain what it means when you are in the early stages of a solar cycle. Does it increase your chance of a colder winter? We think that when you're in the early stages of the solar cycle, you are increasing the chance of a colder winter. The best chance of a colder winter, or a couple of colder winters maybe, is in the first year or two of the new solar cycle. And we'll try to confirm confirm that through reanalysis. We will try to confirm that with reanalysis later on in the winter updates. Thank you so much to Richard for sending that through. In round update number 3, you'll see the swingometer from Richard as well. Our king of swing will be trying to verify exactly how the winter updates are progressing in terms of whether they're pointing to a cold winter or whether they're pointing to a mild winter. But we need a couple of weeks worth of data before we get the swingometer working, so that will be for round update number 3. Right, let's deal with the oceans then. So we're going to be looking at 4 specific areas with the oceans for this winter update. So we're going to be looking at the Enso region, of course. We're going to be looking at the Northern Pacific over here, of course. We're going to be looking at the North Atlantic over here as well. And for this year's winter update, because it's a question that so many people have had, we're going to be looking at the Indian Ocean as well. The Indian Ocean Dipole. I'll be attempting to explain what the Indian Ocean Dipole is very shortly. So, let's deal with the Enso region first of all, though. So, this is how things look in terms of the ocean. We did the last GavsWeatherVids Sunday roundup last Sunday. So, that's how the oceans were looking as of the 26th of August. Let's have a look at the latest. So, this is the latest we've got from NOAA to the 4th of September. So, let's compare the two. And you can see that in the Enso region, La Nina is continuing to strengthen. This blue area just here is colder than average. Sea surface temperature anomalies. That is a signal for La Nina. The winter of 2020-21 will be a La Nina winter. There's no doubt about it now. Winter of 2020-21 will be a La Nina winter. The question is going to be, how strong does the La Nina get? You can see that over the past week, La Nina has continued to intensify. Again, that situation last week, this is the situation this week. You can see that particularly in the eastern part of the equatorial Pacific, the La Nina is continuing to strengthen. At the moment, in the central part of the equatorial Pacific, we are still at week levels, but this is like moderate La Nina threshold, and if it carries on strengthening, that might actually get to strong La Nina threshold over in the eastern part of the equatorial Pacific. Those cold average sea surface temperatures are gradually inching their way along the equator of the Pacific Ocean, and we'll be having to monitor this every week to see exactly how strong this La Nina is going to get. There's no doubt, I don't think there's any doubt, that winter 2020-21 will be a La Nina winter. The question is whether it will be a weak La Nina winter, whether it will be a moderate La Nina winter, or whether it will be a strong La Nina winter, and we won't know until we go further on through the weeks and we see how this continues to develop. Of course, later on in the updates, we'll be attempting to answer through reanalysis and analogues exactly what does it mean when you have a La Nina, be it weak, moderate or strong, and that will be coming up later on in the winter updates, of course. Moving northwards into the Northern Pacific Ocean. Again, this is how things are looking in the Northern Pacific Ocean. So warmer than average up there, very significantly so. And this has been an omnipresent sort of feature, these warmer than average sea surface temperature anomalies here, been an omnipresent feature for several years. I think we first started seeing this around 2014. Did have a year off during 2017-18 during that winter, but generally been pretty warm up there over the past years. And we know that this has tended to be associated with the milder winters that we've been having over the past few years as well. Again, that cold winter we had in 2017-18 with the beach from the east was associated with colder than average sea surface temperature anomalies just here. But all of the other winters that have been very mild since 2014, they've generally been associated with warm and average sea surface temperature anomalies. It tends to send the jet stream northwest to southeast like this across the United States, and that can pull cold air, of course, down into northern east parts of America. As that cold air hits the Atlantic, it can blow up the jet stream and create cyclogenesis and run the jet across the Atlantic with deep areas of low pressure. So if anybody wants a cold winter, I know a lot of people who watch this want a cold winter, you will be wanting to see this area going cold. And now, helpfully for that, we have got a La Nina going on. So what La Nina does, it sort of turns down the thermostat. So you think that if El Nino is like you turn up the thermostat and you pump heat out of the Pacific Ocean, out of the equatorial Pacific Ocean, northwards through the Pacific, and eventually that will probably arrive like into the Atlantic as well. with an El Nino you do that, but you also do it with a La Nina too. And a La Nina is where you turn down the thermostat. So eventually, this La Nina, particularly if it starts to take off, eventually this La Nina should start to cool down the oceans. We will probably see it in the southern Pacific Ocean first of all, around here. We'll probably see this area starting to go cooler. But eventually, we should start to see this La Nina beginning to cool things down up here as well. Because of how quick that happens, there is a time lag on this, so it might be that we don't see like the Northern Pacific Ocean cooling down till next year after this landing. It's possible that's what will happen, but it could happen quicker than that. And so through this season of updates, we will of course be keeping an eye on these sea surface temperature anomalies in the Northern Pacific. But at the moment, they remain in a very warm state up there in the Northern Pacific. Again, comparing them to last week, you can see how warm they are compared to last week. In the North Atlantic, we've got a warm North Atlantic Ocean as well, so it's just generally warm and average through most parts of the Northern Atlantic, particularly here from like Newfoundland up towards Greenland. Very warm through there. The tropical Atlantic is also pretty warm. That's why we're having quite an active tropical storm, if not hurricane season at the moment. Norwegian Sea is also looking pretty warm as well. In a future update, we will attempt to work out when the last time was that we had the Atlantic Ocean this warm. Then we move over to the Pacific, to the Indian Ocean, I should say. So we've got the Atlantic just here, we've got the Pacific just there. We move beyond the Pacific into the Indian Ocean just here. And this is something that a lot of people have been asking about as we've been building up to this season of winter updates. Last year we had a very positive Indian Ocean dipole, and I'll explain what that is in a moment. But it was believed, I don't know how this would work, because it's a relatively small ocean compared to the Pacific and the Atlantic, particularly the Pacific. So I don't know how this would work particularly. I've got to do a lot more research on it. But it was believed last year that the very positive IOD we had, Indian Ocean Dipole, was probably at least partly responsible for the very mild winter that we had last year. So let's go back to last year's sea surface temperature. And of course, we're using the old version of the anomaly maps at NOAA. So look at the difference with the Indian Ocean last year to this year. So this is from the 5th of September last year. Notice we got these cooler than average sea surface temperature anomalies just here in the eastern part of the Indian Ocean. Meanwhile, through here, it's warmer than average. That is the positive phase of the IOD. That is the positive phase of the Indian Ocean dipole. Compare that to situation now, you can see that it's like reverse really. So just here it's pretty warm, and over here it's actually cool. It's not particularly cold, but it is cooler through the western part of the Indian Ocean, and it's warmer in the eastern part of the Indian Ocean. So it is a very different setup that we've got this year compared to the same time last year. A very, very different setup. Now, as you know then, this is when the positive phase of the IOD reached its peak. So, again, look at how we've got these colder than average sea surface temperature anomalies just here in the eastern part of the Indian Ocean, and then in the western part of the Indian Ocean, it is warmer. That is when the positive IOD reached its peak. And again, that's a very, very different setup to the setup that we have now, where it's warmer here. So where it's cooler last year, it's warmer, and where it's warmer last year, it's cooler. So that means that the Indian Ocean is set up very, very differently to how it was last year. This is from Bureau of Meteorology, which is part of the main forecast agency in Australia. So again, this is depicting the IOD, the Indian Ocean Dipole Index time series, all the way back to 2016. What you'll notice, of course, is so we've got our sort of anomalies on the side, temperature anomalies on the side, in terms of sea surface temperature anomalies in the Indian Ocean, and then we've got our dates on the bottom, monthly periods. What you'll notice is this this massive spike just here, this massive spike that we have just there. That is the positive Indian Ocean dipole, the positive IOD that we had during the autumn of 2019, lasting into like the end of the year. It did cool down quite quickly, so by the time we get through like into the spring of 2020, we are actually into like a neutral phase of the IOD. But you can see how the IOD just took off through 2019, really spiked up into a very strongly positive phase, went above 2 Celsius on the index before coming down. Now, as it comes down, of course, there's going to be a time lag. So although the positive phase of the IOD last year reached its peak, you know, kind of like around the autumn of 2019, that would still have impacted the winter, because there is always the winter of 2019, because there is always a time lag between bringing the temperature down and having an effect on the atmosphere. And it's believed, I don't know how this will work particularly, if anybody does know how this works, let me know in the comments. I'm going to have to do a lot more research on it, but it is believed that this positive phase of the IOD was at least partly responsible for the polar vortex of doom. You'll notice the last time we had a cold winter, which was 2017-18, the Indian Ocean dipole then is hovering around very slightly negative. So the last time we had a cold winter, 2017-18, was a slightly negative IOD. Where we are right now is just here. We are actually in a negative phase of the Indian Ocean dipole, and we've explained why, the flip around in terms of those sea surface temperature anomalies in the Indian Ocean. Let's go back to it. So this just here is why we are in a negative phase of the IOD at the moment, because it's cooler there and it's warmer through there. Now, the model forecasts for the IOD are looking like this. So we've got various models here. Again, this is from Bureau of Meteorology. So we've got the Bureau of Meteorology's own model just there. We've got CANSIT's there. We've got the ECM DF there. We've got Meteo France is there. NASA is there. UK Met Office is there. And this is like a mean of all those models. So the forecast for at the beginning of September, for September, is, and that's for these grey areas just here, all models are forecasting the IOD to either be neutral to slightly negative during September. They are all forecasting the IOD to be either neutral, slightly negative. We've seen the reason why, because of how the Indian Ocean sea surface temperatures are set up. If we move through to October, we can see that most of the models are forecasting the negative phase of the IOD to strengthen in October. So most of these models are going to negative. And also you have to be around 0.4 degrees below average to be in a negative phase of the IOD, and 0.4 degrees above average to be in a positive phase of the IOD. Anything in between, I assume, is like neutral. So most of these models are forecasting the IOD to go more strongly negative, actually, as we go through into October. Most of them are going more strongly negative in October. Still looking negative with most of these models in November as well. You'll notice CANSIPS and the UK Met are pegged back more. They're much more towards neutral, but the other models are generally reaching, just about reaching negative threshold for the IOD. In December, this negative phase of the IOD starts to back off a little bit, but most of them are still like neutral to negative. As far as we can go is to January, when again, most of these models are still in a neutral to sort of weakly negative phase of the IOD. We do have a couple, though, that by January, and it's CANSIPS and it's Meteo France are just going slightly positive, sort of neutral to positive. But bear in mind, I mean, there will be a time lag on changing the IOD, same as any of these indexes. There will be a time lag on changing the IOD state and it having an impact on the atmosphere. So if the IOD was to go weakly positive, for example, in January, probably wouldn't affect things until like 2, 3, 4 months further down the line. So it looks like this winter 2021 should be like a negative, neutral to negative IOD winter in terms of the atmospheric state anyway. As far as Enso is concerned, just talk about this very quickly. This is from Queensland Government, oscillation index. This is, I'm going to hear much more about the IOD in the coming weeks as well. I know so many of you have had questions about the Indian Ocean Dipole. You will be hearing much more about it in the coming weeks. Right, okay, so this is the Southern Oscillation Index. Index that's reflecting atmospheric state of the Southern Pacific Ocean when the SY is in its positive phase. Then the atmospheric setup will be reflective of El Nino when the SY is in its negative phase. When the SY is in its positive phase, the atmospheric setup will be reflective of La Nina. When the SY is in its negative phase, the atmospheric setup will be reflective of El Nino. Let's scroll down. So you can see that the SY is in a positive phase, and that's why the La Nina is developing. So 29th of August, we come out at plus 18.63. 30th of August, we come out plus 22.70. 31st of August, we come out plus 21.36. 1st of September, we come out plus 18.66. 2nd of September, we come out at plus 20.15. 3rd of September, we come out plus 12.60. 4th of September, we come out at plus 6.73. And 5th of September, we come out at plus 8.56. These are positive numbers, and it tells us that the atmospheric state in the Southern Ocean is reflective of La Nina, and that is why La Nina is continuing to develop. And we can see that from the 30-day SY average, which is this red line, we are moving upwards with the 30-day SY average. We are increasingly moving into positive phase, although it has dropped down for a couple of days. I think the general trend quite clearly from there to there is upwards. We also have the 90-day SY average moving as well, which is this orange or yellow dashed line. That's moving upwards too. Everything is pointing us to La Nina. Everything is pointing us to La Nina for the winter of 2021. CFSB2 is now forecasting a moderate La Nina, just about. So, again, black dash line, we've got temperature noise on the side, dates on the bottom. All important number is half degree below average or half degree above average for El Nino or La Nina, respectively. So you can see we have reached that all important half degree below average threshold to get to La Nina. See the black dash line falling away here, going to around 1.5 degrees below average at the peak of this La Nina event, sometime around November or December. That is just about to moderate La Nina threshold. So CFSV2 is forecasting a moderate La Nina for the winter of 2020-21. I suspect that probably is a little bit overdone. But we'll see. We'll see if the sea surface temperature anomalies in the equatorial Pacific continue to fall away. Right, next thing we're going to look at is going to be the 2020 Atlantic hurricane season. So we are on the 2020 Atlantic hurricane season page at Wikipedia, and these are how the scores on the doors are currently looking in terms of this hurricane season. So far we have had a total of 16 total depressions. We have had 15 total tropical storms. We have had 5. That is a very high number, by the way. Those are two very, very high numbers for this early in the season. Bear in mind, I'm only recording this on the 5th of September. Those are phenomenally high numbers for total depressions and total storms. We've had 5 hurricanes, which is pretty high as well, but only one major Category 3 or above hurricane, which is possibly a little bit of a surprise, given that we have had a total of like 15 storms and so on. So yes, this has turned out to be quite a strange hurricane season. Now, I'll just explain why we look at this. So the reason we look at this, let's go back to the sea surface temperature anomalies. So the reason we look at this is that hurricanes are basically a way that the Earth cools itself down. So hurricanes are a mechanism for transporting heat from the tropical Atlantic, Gulf of Mexico, all of those sort of areas, and the same is true for like the tropical Pacific as well, in terms of typhoons. So it's a way that the Earth transports heat from there to here, all through low pressure, and ultimately up to here. The Earth is always looking for equilibrium. It's always looking for balance. And so these storms and hurricanes are basically a way that the Earth can control its temperature by transporting heat from the tropics up to mid-latitudes and eventually into the pole. If you have lots of hurricanes, lots of storms transporting heat from the tropics into the pole, the theory goes that it should later translate back into an increased risk of northern blocking if you have lots of these storms doing something like that. Remember, when they get to polar regions, they'll just be areas of low pressure. But it's still a way that the Earth sort of transports heat from the tropics to the poles via the mid-latitudes. You have lots of storms, lots of hurricanes transporting heat and dumping it in the pole. It can could translate that to an increased chance of northern blocking. This is a Joe Bastardi theory. Joe Bastardi from AccuWeather and now Weather Bell, and we've been including this in the updates over the past few years. And I know it's a little bit controversial, some of you have doubts about it, but Joe Bastardi is a very, very good forecaster, and so it's something that I have been including in these updates for quite a while now. Now, this is turning into quite a strange season. So, although we are having a very, very big season, in terms of ACE, which is accumulated cyclone energy, which is basically the amount of energy that these storms are giving out, we are actually at a very, very low level. So, our good friend Sean Bruin, created this for me, this spreadsheet. So, this is showing all years of ACE, all the way back to 1851. Thank you so much, Sean, for creating this. So, you can see that in the year of 1851, we actually have a below normal ACE number for that hurricane season at plus 36.24. Let's scroll down. So the category is like below normal, near normal, above average, or hyperactive. There are the four categories. So you can see that our last hyperactive season was in 2017. The last time we had a hyperactive season was in 2017. That was before cold winter of 2017-18, of course. Before that, the next hyperactive season was in 2010. Had a hyperactive season in 2010 before the December to remember, of course. Then we have 3 hyperactive seasons just here for 2003, 2004, 2005. Those aren't followed by particularly cold winters. Anyway, the current year is 2020, of course. So, again, these are the scores. We've got 15 storms, 4 hurricanes, and one major hurricane. Right, so the ACE number, though, despite the fact we've got a lot of storms, the ACE number for this season so far is only at plus 40.10. That's very, very low. Last time we had a below normal season in 2015, the ACE was 62.69. That's last time we had a below normal season. So if we was to keep that ACE number, for the rest of this season, then this would actually turn out to be a below normal season for ACE, even though we are having an abnormally active season in terms of storms. So what this is telling us is that whilst we are getting a lot of storms for this season, so far they are not giving out all that much energy. Presumably it's the energy that transports the heat from the tropics to the poles, if you're following what I'm trying to say here. We're very early in the season, though. We are very, very early in this season. We've still got virtually all of September to go. We've got October to go as well. We will probably see that ACE number increasing a lot, I would have thought. But we will see. At the moment, this is a very, very unusual season. And in another update, we'll try to verify how unusual this season is. But it is very unusual to have so many storms, 15 of them, but such a small number for accumulated cyclone energy. That is very, very unusual indeed. Right, I'm going to pause the video there. So I've been talking for 32 minutes. I'm going to pause the video there, and I'll see you back very, very shortly, and we'll go through the rest of the first Winter 2020-21 update part 1. See you very soon. Okay, we're back, and we're ready to resume the first Winter 2021 update part 1. So if you enjoyed this video so far, please give us a like on the video, let us know in the comments what you think. Make sure you subscribe to the channel, and we'll be releasing winter updates every week between now and the end of November. So let's carry on then. I'm going to move on next to how things are looking in terms of zonal winds in the above the North Pole in the Northern Hemisphere. So here we go then. This is from weatheriscool.com. We have got lots and lots of different coloured lines here. This is for the 2020-21 season. So the main line that you need to note is a black line. That's like the trend line. So you can see at this time of the year, the zonal wind should be powering up. Got our dates along the bottom. Of course, that's September, that's October, that's November, that's December, that's going to be January, that will be February, and that will be March. So at this time of year, the black line shows that zonal winds should be increased. Remember, zonal winds is like the engine that's driving the polar vortex, essentially. So at this time of year, the polar vortex is beginning to reform. We know that last week we had the polar vortex of doom. More about that in a moment. So the polar vortex is beginning to reform at this time of the year, and this will start to power up so the zone winds will start to power up the polar vortex, if you see what I mean. And the polar vortex will be like the engine that drives zonality and westerlies. So the red line, the red dash line, is last season. So we can see that at times through last season, winter 2019-20, we had record-breakingly strong zonal winds on many occasions. We had the polar vortex of doom. It was absolutely phenomenal how powerful that polar vortex was. Now at the moment we're just here, so we're about average, but of course we're only in the beginnings of this season in terms of powering up the polar vortex. The GFS ensembles are forecasting that, if anything, the zonal winds at 10 HPA in the stratosphere over North Pole might weaken slightly in the next couple of weeks. They might just weaken a little bit. The other coloured lines, there's 4 blue lines. These are from the CFS V2. And so we can see that as we move on through the autumn, so again, this is September, this is October, and this is November. We can see that as we move on, and this is December now, as we move on through the autumn, CFS V2 is generally forecasting quite weak zonal winds. It does have, because it's run 4 times a day, so one of the 4 is going for like average in terms of the zonal wind, strengthening it up to average. These ones just here, though, the other 3 are actually weaker than average with the zonal wind for November. And interestingly, all members, all 4 members of the CFS V2 suite forecasting that zonal winds will stay weaker than average as we go into December as well. A couple of these are actually going for a reversal of zonal winds. These 2 down here are going for a reversal of zonal winds. Only a very slight one, but a reversal of zonal winds in November, which would be very, very unusual. But generally, it looks like the CFS V2 is quite keen to keep the zonal winds weaker than average through this autumn, and possibly even into December. You remember, of course, what happened last year, and you can see it from a red dash line, is that virtually on the first day of December, just there, we saw the zonal winds taking off. We saw the polar vortex of doom ramping up virtually on the first day of meteorological winds. But if this forecast is right, remember, the CFS is unreliable. If this forecast is right, zonal winds should stay generally quite weak. The zonal winds should stay generally quite weak right the way through the autumn and into the beginning of December, and that means that zonality should be a little bit weaker than it was. It should be quite a lot weaker than it was last year as we move through the autumn into the winter. Is how things look in terms of Eurasian snow cover. We'll move on from this very quick because there's very little to see. Just got a few little smatterings of snow here across eastern parts of Siberia, but generally still snow free. Eventually all of this is going to fill up with snow, but that will be more sort of late September into October. I know that's one of the parts of winter updates that virtually everybody loves to see, the snow line pushing across Siberia, but at the moment there's very little to see there. In terms of Arctic sea ice extent, this is from National Snow and Ice Data Centre. Big season, big melt season again. As we know, the blue line is for 2000 and it's for 2020, so that's where we currently are. We're virtually up the peak of the melt season now. Probably got about another week, maybe 10 days of melting to go, and then the refreeze will commence. Let's see how this compares with 2012, which is the record minimum year. So we are actually now getting quite close again to 2012. We're just there. The red dash line is 2012. So yeah, it's possible we'll reach parity with 2012 in the next week to 10 days. It does look as though this blue line doing a little bit of a plone. It's only going to go down to there to reach parity. The reason we look at Arctic sea ice extent is that there is a belief that, again, if you have big melt season, it can translate back to an increased risk of northern blocking. So having a big Arctic melt season like we're having this year might translate back to an increased risk of northern blocking for this winter. But it is controversial. Nobody knows a great deal about it, and there's a lot of research currently going on at the moment with conflicting signals. In another update, we'll see how this year compares to previous years. That will probably be next week. And then the last thing we're going to look at for this update is going to be the QBO. So quasi-biennial oscillation, again, it's just an index that's reflecting the atmospheric state. This time it's telling us how strong the zonal winds are. When the QBO is in its easterly phase, then you weaken the zonal winds. When the QBO is in its westerly phase, then you strengthen the zonal winds. So easterly QBO QBOs can be associated with an increased risk of a colder winter for the Northern Hemisphere, and Western QBOs can be associated with an increased chance of a milder winter. We should be in a strong easterly QBO phase right now. This is 2020, so we have these negative numbers through the early part of the year, but notice how they sort of fade out. They become less negative. They should be getting more negative. As we're going on through 2020, these numbers should get more negative. They've got less negative. And actually, as we go into July, we go very slightly positive. We go very slightly back towards the Western QBO. The latest number for the QBO in terms of August 2020 comes in at plus 4.78. That is back into the Western phase of the QBO, and so it would appear that we have had another failure of the Eastern QBO. It would appear that the Eastern QBO has failed again, as it did in 2016. Would appear that in 2020 we have had another failure of the Eastern QBO, as we've gone from these negative numbers into positive numbers, back from easterly to westerly phase of the QBO. Or have we? Let's just finish up with this. So this is from NASA. So these are showing the Western and Eastern QBO phases. This is the last Eastern QBO phase that we had in 2017-18. This is the last Westerly QBO phase that we had from 2018 to 2019 to just at the start of 2020. This is where we are right now. So what should have happened is that the Eastern QBO up here should have descended. Should have seen the Eastern QBO descending through the stratosphere into the troposphere. What actually happened is that the Westerly QBO clung on. Westerly QBO never really went away, and in the past couple of months has really strengthened, and that's why the number there that we just saw a moment ago from NOAA has shifted from negative to positive. Look what's going on at the very top of the atmosphere, though, in the stratosphere up here. It does appear that the Eastern QBO could be starting to come back. If we go back to just here, that's where the Eastern QBO begins, just there, and it should have descended downwards. Looks like that could be starting to happen again in the stratosphere just here. At the moment, we still have the Western QBO in the troposphere, but it does look as though above it in the stratosphere we might be starting to see the Eastern QBO come back. Let's just zoom in. And we can see that right at the very top of the stratosphere. So this is like the very top of the strat at 10 HPA. We might be seeing signs of the Eastern QBO beginning to reappear. But we need many more weeks to go. It's going to take many more weeks before we can say one way or another whether this Eastern QBO is coming back. We will, through reanalysis, look to see what an Eastern Western phase of the QBO could mean for this coming winter. But that will be much later on in winter updates this year, I think, as we wait to see exactly how things are going to play out with the QBO. Right, just tell you what we're looking at tomorrow for part 2 of the Winter 2021 update, first Winter 2021 update. So part 2, we'll be looking at August CT, so we'll be looking at winters following the warmest August on record, given that August 2017 came out of CT at 17.6. And we will also be looking at summers that follow, let's scroll up, we're looking at summers that follow winters that follow summers with a CT of 16 or of around 16.2. The range is actually 16.0 to 16.4, as that's where summer 2020 came out. Okay, so that's it. That is the first Winter 2021 update done and dusty. Just over 40 minutes. I had a lot to talk about with the IOD. I'm going to try and get these to like between 30 and 40 minutes generally. I did have a lot to explain with the Indian Ocean dipole, so I'm very sorry about that. But now that is explained, we won't need to go into that in-depth explanation every week on that. So I'm going to try, hopefully these updates will be coming out between 30 and 40 minutes regularly. So that's it for the first Winter 2021 update part 1. We're going to be back tomorrow at 8 PM with part 2, which is going to be the analogues. We're going to have the analogues again, looking at all of that summer to winter data and August to winter data. If you enjoyed this video, please give us a like, let us know in the comments what you think, and make sure you subscribe to the channel. And we're going to be back with part 2 for you at 8 PM tomorrow, which will of course be an analogues extravaganza. For part 1, that's all for now, and thanks for watching. I'll see you at 8 PM tomorrow for part 2. Bye for now.